Hello everyone, welcome back to another Leetcode Daily. So today our problem is bitwise ORs of subarrays. So what we have to do here, we are given an array or ARR and we have to return the number of distinct bitwise ORs of all non-empty subarrays. Means we have to calculate the OR values of all subarrays which are possible, and then we have to store all the distinct ORs in a resultant array, and we have to return the size of the resultant array. Now, the word distinct. Since we have to store distinct or values, the only things which come to our minds is a use of a set. Why? Because a set never stores a duplicate element. So since it is distinct, we'll be using here set. Coming to the algorithm, first let's discuss the algorithm. So here we need three sets: next, current, and resultant. Why? See, we have to store distinct or values. Now this is a so first if we discuss brute force approach. So brute force approach will be we are iterating big of n square and we are like calculating all values in each subarray, right? So after doing all values calculations for each subarray, we'll store it in a set and that's how the brute force will work. But here what we are doing, this is a kind of DP we are using. How? Just see. Here we are using the three sets, next, current and resultant. So next set will store the OR values of each new member. So we are iterating in an array and for each new member, we are doing OR operation with all the elements of current set. And what the current set stores, current set will hold all OR values from the last step. So till the index before it, with all the subarrays or values it will store. Distinct or values it will store. And in each step, we are storing the previous results and we are just executing or calculating the next or values and we are storing it in the resultant array. Now, what is the resultant array? It keeps track of all the results we get. It will keep track of all the or values results with each subarray we get, and it will store it in a set, resultant set. So, how a DT is being used here? So, here it is the explanation. At every index I, so whenever we are going to a new index, we are computing a set current. Now this set current will contain all possible or results of the subarrays ending at index I. Now for the current index, we are calculating again the OR values with the previous OR values and we are storing it in the next. So what we do? Let's discuss. The step 1. We hold the OR values from the last step, okay, and those are stored in current set. Second step, at each new index, make a new group with the number or with that particular index number and do OR operation with everything we held before. Means we will do OR operation with all the elements of the current set and we will keep track. Step 3, we will keep track of all the results we see. So we will keep track of all the OR values in the resultant set. And at the end, we have to like, we have to print the size of the resultant vector. Means we have to tell them the number of distinct bitwise ORs which are possible or values which are possible. So we just return the size of the resultant set. Now, once we will go through the code, we'll discuss this algorithm again and then it will be clear. Starting here. So, as I told you, step number 1, let's first create three sets: next, current, and result. Okay. Now, the first step, we have to iterate over, all the elements of the array. Now we are iterating over this. So we are just storing this particular element in a next vector. So we are inserting next में I, and then we are iterating through all the elements of current. Now we are iterating over all the elements of the current set. Now what it will do? We have the current set elements. So what current set elements hold? If you remember, it will hold the previous OR values. It will hold all the distant OR values till this particular index. So we are just ORing it with the previous results. So here next dot insert again I or X. Now we are inserting this particular elements or value to as a new group to next element, and after this we will store this next in current, okay, and then we will like current is replaced by the new next, and what we do, result, in the result we have, right, in the final vector we will push current dot begin and current dot end. Means it will store all the values in the current to the resulting vector. But there is one thing remaining. For each iteration, you see here, for every new element we are getting, the next should be empty. So at every iteration, we are just making the next dot clear, means it will empty the next set. Okay. And now we will return the size of resultant set. So let me tell you the steps once more. So what we did, we first made three sets. So here we made three sets. Here we are iterating over all elements of array. Now here we are inserting that particular element, insert the index element to next, and then we are inserting inserting all the, means what we are doing, we are inserting the particular all the or values, inserting all the or operation values to next, and or operation किसका, or operation of this particular index, or operation of this index element with all current elements. And what are current elements? Current elements hold the previous or values, previous distant or values till this particular index. So we are not iterating, we are not counting again and again, we are not calculating again and again all the or values, but we are storing it in the current as a DP. So this is a kind of DP state we are using here. And then we are storing, so we are storing, or rather we are replacing current with next, and we are storing all the resultant values in the resultant array set, and we are returning here distinct or val size, means numbers, val. That's it. So this is all the algorithm. Now let us try and run this, and then we'll discuss the complexity. So this works. Let's sum it, and yes, it got accepted. So coming to the time complexity. So time complexity here is, first we are iterating through all the n elements, then we are iterating through all the current elements. Yep. So time complexity here is big of log. So what we are doing? We are iterating through all the index of array. So suppose n is the size. of the array, so n, and then we are using like we are iterating through all the current elements. So we are suppose n is the maximum maximum elements possible in the array. So that is n log m. And coming to space complexity, again, are we using the space here? Yes. So it will also be, since we are using different sets here, it will be m, where m is maximum size of elements in array AR. So this is our time complexity and space complexity, and you can see it got accepted, and that's it. Thank you, and yeah, thank you so much.